Thank you, Gunjan, so much for your talk and great Q&A. For our next speaker, we have Shep Walker. Shep is a software engineering manager at Stripe, working to improve Stripe's internal documentation, source control, code intelligence, and effective use of AI for software engineers. He brings significant software development experience, particularly in technologies like C Sharp, SQL, Java, and the .NET framework. And today, Shep will be talking to us about code discovery for AI agents. Shep, over to you.
Hey folks, my name is Shep Walker. I'm an engineering manager at Stripe in our developer productivity org, and I'm here to talk to you about code discovery for AI agents and some of the experimentation that we're doing to improve our engineers' productivity in partnership with Sourcegraph. So, first, let's talk about some of the challenges that we're facing at Stripe. We have thousands of engineers and 20 million lines of Ruby code in a single repository. And in addition to this, we have a very large Go repository as well as a Java repository. We're also incredibly opinionated about our coding conventions, and this is the clearest example of this is our Ruby code is heavily typed using the sorbet project. What this has ended up leading to is with coding assistants, there's this big expectation gap between what folks realize when they're doing greenfield projects or personal side projects versus what results they get from building tightly integrated features into large code bases with significant incoming and outgoing dependencies. One way to address that expectation gap is to try to figure out a way to get LLMs to reason over a broader set of complexity. And the direction the industry is going seems to be in these coding agents. So essentially, how do you take an LLM, give it access to a bunch of tools, do some LLM calls in a for loop with an objective function, and improve your results that way. And there's been a ton of work here. So one interesting project is SweBench, which is a state-of-the-art benchmark for coding agents. So very cleverly, they took a bunch of GitHub issues that have tests associated with them, and then they throw these agents at them in a sandbox and see whether or not the agent can successfully write code that addresses the GitHub issue that makes the test pass. But we have a problem in that if you look at the repositories that are within this benchmark, the largest of them is still about half the size of the code base that we work with every day at Stripe. And to be clear, that's for very good reasons. Like these benchmarks are already really hard for LLMs to tackle, and they're exceptionally expensive for like labs and tool makers to run. So, with that in mind, we've been thinking hard about what we can do to accelerate the usefulness of agents within Stripe, and where do we need to invest somewhat uniquely in order to drive our own improvements. And there are essentially two main areas of interest that come to mind. One is code navigation, which, given an open-ended prompt on a feature to add or a change that needs to be made, can a coding agent successfully find the right files that need to be edited? Or, you could even simplify it to could successfully get to a subpath in a large repository. The second is code understanding. So, given a piece of code, can a coding agent figure out how it works in the deeper context of incoming and outgoing dependencies more than just what the context within the file would give it? There's a ton of potential context that LLMs can use in order to both address code discovery and code understanding. It can analyze diffs. We can use BM25 or vector search. There's also just a ton of additional context stored in the ASTs of the code we write, right? So language servers can understand this, debuggers can step through it, and there's a lot of rich structure that an LLM can reason over. But like we already have a pre-baked index of our syntax tree and a way to query it through Sourcegraph. So why don't we just lean on the tools we already have and see how far that gets us? And that leads me into my demo. So just a little bit of background. This demo is using a open source agent platform called Goose, which was built by the fine folks at Block. And the tools you're going to be seeing Goose use are built by Sourcegraph based off of some feedback and collaboration that Sourcegraph had with us at Stripe. Um, these tools are about 2 weeks old. So this is a very early demo, but I think it really shows a lot of the promise of kind of leveraging code context and code intelligence inside of a coding agent and kind of getting outsized results there. If we pop over onto our terminal, this is a little Goose session I have going. Now, I don't think any of y'all want to watch me type for 30 seconds. So I have this prompt pre-written. It's pretty explicit. So we're kind of spoon feeding the syntax a little bit more than I think we want to eventually. But this is still a very powerful example of uh, the LLM being able to use Sourcegraph to find the right shape of changes to make, and then this effectively doing a code mod across all of those examples. Cool. Oh, wow. All right. So it returned everything kind of at once. So, okay. It ended up limiting some prop types. It added an interface for provider props. Um, and yeah, this looks roughly correct across the board. Okay, cool. Let's try another example. So I'm pretty pedantic, so I don't like this whole is server constant. So we're gonna change it to is a server and see whether or not it can make that change for me. So the thing I like about this example is it does a little bit more of a second order lookup. So it's not just, hey, here's the variable, but also here are all the references to that variable. Oh, all right. So it returned kind of all in one fell swoop. All right. So I see references being updated. Let's see if the actual, okay, is server to is a server across the board. And then, yeah, it looks like we have also the core variable edited as well. This is awesome. Okay, great. Um, okay, so let's wrap it up real quick. Agents are very promising when it comes to reasoning over large code bases and trying to make coding assistants as useful for folks' day-to-day code bases as they are for like net new greenfield projects. There is a ton of unexplored ideas here, and many research opportunities for folks to go try to figure out how to give LLMs the context they need and the capabilities they need to reason over large code bases. But I think a very, very important component to this is going to be, the precise indices that we have today that you can query fairly easily in Sourcegraph. So thanks so much.
All right, Shep, that was pretty awesome, and that Goose demo was amazing. So
Yeah.
is that can you tell me a little bit more about the Goose thing? I mean, like, how did you build it? I mean, like, and is
So
the LLM still responsible for updating it and so on?
yeah, I want to be very clear. So we didn't build Goose. The folks at Block built Goose, and we saw it, and we were just like, that seems neat. And so we've started experimenting on top of that. And if folks are curious, I linked to the GitHub repository in chat. Like we had a relationship with them after kind of talking at a few conferences, and like their approach to building kind of an agentic framework for coding seemed really mature. And so we started playing around, plugging it into Stripe primitives. But we quickly saw around the corner, like, hey, this is going to hit the point of diminishing returns really quickly unless we can get some degree of code understanding. And so, like, we did a little bit of research around, like, can we just get this to talk LSP, like just plug it directly into a language server? But like, we're already generating skip indexes, and we have a service that knows how to return skip indexes, and that struck up a conversation with y'all, and got this demo out in like a week and a half.
Wow. So what I mean, what's your vision for how it's going to evolve in the next 6 to 12 months, and what do they have any big gaps that you hope to address?
Well, yeah. I mean, there are huge gaps. Like this is very much an experimental thing. Like if any of the folks listening talk to their friends at Stripe and they're like, "Oh, so do you use this every day?" You have a 99.9% chance of them saying no. So this is like still very much a like figuring out what's possible first. There are a bunch of things we need to go figure out. I think the biggest one that's the biggest question mark in my head is UX, right? Like we already see like, for AI assistants, everyone loves autocomplete, but it's really hard to get them necessarily into the chat window. And so like, how do we like draw people out to use these agents and teach them what it's good at and what it's bad at, in order for them to like work it into their day-to-day flows. The other path we're like looking to go into is do we essentially take one of these frameworks, put bounding boxes on it, and optimize it for very, very specific scenarios. The folks at Uber did a talk about this, about I think they call it coverage bot or something along those lines. So that's on YouTube if people are curious, where they essentially made a few of their steps very deterministic, where they're just like, this thing is going to pump out unit tests, and that's its one job. And like, I think that, unit tests one interesting scenario, but there are probably also domain specific scenarios that are interesting there.
Isn't it interesting how everybody went from, oh, LLMs can write code. Oh, we better have agents that completely replace software engineers. And now, it's gotten so much more refined. Yeah.
Yeah. Like it is getting there, right? Like, I mean, for me, I think the initial thing was like, okay, can we do this in one shot? No. Can we do this in one shot with a great context window? It's better, not quite. Okay. Can we do this like in a loop? And the answer is still not yet, but like it gives us way more knobs to turn in order to like try to bring some of those compounding returns I think y'all were talking about earlier.
Yeah, it's approaching the problem incrementally, right? Which is how all of the other software that we use has grown over the years. Everybody was expecting this huge big bang with AI, that I think, to Quinn's point earlier, there's been a lot of hype around it. But yeah, I mean, sorry, you get me really excited here. I'm very excited about your talk, but I'm gonna go ahead and let other people ask questions. So from Gene. Gene, by the way, Gene Kim is a Clojure user these days, which I don't think has a sorbet-like static type system. So I'm not going to put words in his mouth, but he is totally jealous of yours. So he asks, can you help me make sure I understand this? Is this to reduce the number of types and interfaces to get closer to canonicalizing it, or is it to reduce type checking runtimes, or what's the goal?
Sorry, for sorbet specifically?
I think so.
Yeah. So like we use sorbet for a number of things. Like we do like statically type check both at build time and at CI time. And like just we've seen that be incredibly important for being able to build scaled reliable systems using Ruby. And that's been a huge part of our success. The other thing that we've been able to do is like take our giant Ruby code base and actually turn it into a like directional DAG, which has like amazing attributes in terms of like you can figure out dependencies really easily. You can start services much faster. You can do test selectivity much better. And like that is much harder to do if you don't have like some notion of a structured type system on top.
Yeah. That is the truth. Hey, you mentioned earlier, speaking of structured type systems, that having a stored AST, everything's reified and queryable, and there's indexed and all that. Tell me a little bit about how you're making use of all that rich, code metadata that you've got today to help your code AI. But also, I'm really curious to know. Well, let's start with that, and I'll ask the follow-up question. So,
yeah, I mean, like I think today is essentially what you saw. Like in that little video, which is like we can now query some context, and like most of the things that we've played with are mostly around code mods. I think the thing we need to go figure out is like I think the scenario that interests me the most is essentially context stuffing for like a pre-code suggestion step. So essentially, we know roughly the chunk of code we want to edit, an LLM wants to edit. Then we go out and get a bunch of context. And I think there's like a bunch of question marks there about like, do we do that deterministically, right? Do we just say like, grab everything within this scope and then just bring it into the context window? Do we do that, somewhat intelligently? And that I don't know all the right answers for. I think like the other thing I want to make good use of there is like essentially tell the agent, hey, now that you've edited this method signature, go find all the references to it and make sure that it is updated, so it is actually passing in as param. And I think that unlocks a huge number of scenarios we wouldn't be able to do otherwise.
Yeah. So I don't think that people fully kind of get that you guys have, like we have Sourcegraph. They're not very common. These code indexes that provide this incredible purchase for the LLMs, right? People have been asking questions in the chat, right, about multi-repo context and how does the LLM get the sort of the top-down structural hierarchical context view of all your context. And it seems to me that well, having all that stuff, indexed is going to be a huge boost for that. Yeah.
Yeah. So the index we have are skip indexes, which are a prerequisite for like Sourcegraph precise precise references. And so like we generated those, and then like I think I went through an hour of research. It was just like, okay, I have the skip indexes. Now how do I go query them in a reasonable way? Can I load them up in some sort of like local shell? And then I was like, no, someone else already has a query engine for me and knows how to do this fairly effectively, and that's Sourcegraph. So like all that context is already there, and we update it on every trunk build. So like we can just bring that context in directly from Sourcegraph, and that's what that demo showed.
This is just so powerful. I'd love to come see it in action. I got a question about Sorbet because it's Sorbet I don't think it has a whole lot of usage outside. Compared to what you guys are doing with it, just in terms of training data. I'm talking about how LLMs are biased towards languages that have more training data and they're better at it. So how much difficulty have you had getting the LLMs to pick up like the best practices and the idioms? Have you had to do any special prompting or any training or anything special at all?
Like I think we definitely see, like when we've talked to peers at like peer companies that use Ruby, but like they're using Rails or like they're not using Sorbet, like their acceptance rates are like a few points higher than ours. We haven't done anything clever yet to try to bridge that gap, right? I think there's like an open question of like whether fine-tuning solves this for us, and like depending on the fine-tuning mechanism, like the answer is absolutely not or absolutely, and we just haven't we haven't invested much there. We've tried to do some like manual context stuffing where it's just like, hey, use sorbet types, they look like this, where possible, and that helps some, but I don't think it bridges the gap that our code base being really out of distribution has caused.
Yeah. All right. Well, that's pretty much what I expected, but I think it's going to get a lot better as we get better at figuring out how to use this stuff. So hey. Oh, sorry. Go ahead.
Is no silver bullets, right? So, yeah.
That's right. So next year, 2025, what's the big Code AI initiative? What's top of mind for you?
So there's some discussion in the chat about this, but like we're trying to think critically about what the right way to get coding assist or LLMs in the code review process. I'm incredibly sensitive about quality, ridiculously sensitive about quality. So like I am in constant fear of a bunch of AI assistants just spamming like a GitHub page with results. So like, there's an open question about how do we do that in a way that like adds value, but like gets that balance of like false positives, right? And then I think now that we have like a good superstructure for how we want to do agentic stuff, I think we want to start getting deep into specific tasks, because I think that will bring more of our internal users on board to like understand the power of LLM agents.
Yeah. Wow. Well, it's going to be a big year. Hey, Shep, thanks for coming. We've really appreciated your talk. Everyone loved it. Best to our friends at Stripe.
Sweet. Thanks so much, Steve.
All right, folks, we've got about 20 seconds till the next session. We've learned that we need to actually give it that 20 seconds to be smooth. So I will see you all in 20 seconds.